Hello everyone. Welcome back to the course of data structures using C. This video is brought to you by Newton's Group of Institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. Now, let us see the fourth sorting technique, that is quicksort. So here, quicksort, it is an algorithm to sort an array of numbers. So now my question is, when we say that an array of numbers are in sorted order, we say that it is in sorted order of an array if every element in the array is in the correct position. So now once again my question here is, when we say that the element is in its correct position, so we say that the element is in the correct position if every number that appears to the left of that number is less than the element, and every number that appears to the right of that number is greater than that particular element. So this condition need to be applied to every element in that particular array. So this is the main idea that lets us see what a quicksort is. So here, quicksort is a very popular sorting method and it is an important method of internal sorting. And according to this algorithm, it is faster and easier to sort two smaller arrays than one large one. So here the strategy the quicksort follows is divide and conquer. So in this approach, numbers are divided and again subdivided, and this division goes on until it is not possible to divide them further. So this procedure, what it follows is by using the recursion, and we call this particular sorting technique also as a partition exchange sort. Here the basic idea behind the quicksort is what means in this algorithm we are going to choose one element, that is the key element, which we call it as our pivot element. Okay, so we can either choose the first element as the pivot element, or we can choose the last element as the pivot element, or we can choose the random element as the pivot element, or we can pick the median element as the pivot element. So here there are many techniques what we are going to use to choose the pivot element. And the key process in quicksort is partition. So target of partition is, given an array and an element x of an array as pivot, then we need to put the x at its correct position in the sorted array and put the smaller elements smaller than x before x, and put all the greater elements that are greater than x after x. And all these things, what we need to do, we need to do it in an linear time. Okay, so now let us go with an example. Now say that we have an array with n is equal to 7. That is, we have 7 elements. Let us say that these 7 elements are 11, 16, 2, 3, 10, 17 and 12. Now let us consider that the starting element as an pivot element. So here my pivot element is 11. So the quicksort algorithm basically works using divide and conquer technique. So in divide and conquer technique, what is the main funda is, this complete array is divided into sub-arrays, and this division of arrays into sub-arrays is called as an partitioning. Okay, so that partitioning of an array is the backbone for this particular quicksort algorithm, and this is the main funda of the quicksort algorithm. Now, my question is how to partition this array. This is the main part of this particular algorithm. And if we know how to partition this array, then we can easily write the code for the quick solve. Okay. So in this particular case, 11 is our pivot element. So here we are going to partition our array such that the elements less than 11, that is the pivot element, would be towards the left side of the pivot element, and greater than the pivot element would be towards the right side of the pivot element. And if any element which is equal to this particular pivot element can exist in either ways, that is either towards the left side or towards the right side. Now let us see how to partition this particular array. Here we have pivot element. So this is our pivot element, or we can say that the key element as the pivot element, and this is my partition 1, and this is partition 2, and all the values this side would be less than the pivot element, and all the values this side would be greater than the pivot element. And the equal values can go in either way, either in this way or either in this way. Okay. So this element we can also say as the key element. So this pivot element can also be called as the key element. Now we have to find the proper place for one element. So this 11 should be placed at the proper place. So where that pivot element, that 11, where we have to place. Now this array has been divided into two parts. One is this one and the other one is this one. Here we cannot say that the values that are in the partition 1 are in the sorted order. The thing what we can say is the elements that are in the partition 1 are less than this particular pivot element. They need not be, or we cannot give any guarantee that the elements that are being present in this partition 1 are in the sorted order. And the values in the partition 2, that is right side. So these elements are greater than the pivot element, but there is no guarantee that these elements are in the sorted order or these values are in the sorted order. So neither these elements nor these elements in the sorted order, that guarantee we cannot give. Now again what we are doing is we are going to apply the same funda. So we are going to apply the same funda for this particular array, subarray, and the same funda for this particular subarray. So now again we are going to partition the subarray into two parts, and this subarray into two parts, and again this subarray into two parts. Okay, we are going to continue until we are going to have one element. Until we are going to have one element. If 11 we are considering as an pivot element. So if 11 we are considering as an pivot element, then say 10, 2, 3 will be to the 10, 2, 3 will be to the left of this 11. And similarly 17, 16, 12. So 16, 12, 17 will be to the right of this particular 11. Now this 10, 2, 3 is one subarray and 16, 12, 17 is an other subarray. And 11 is at the correct position. Now we need to apply the same funda or same technique for these two subarrays. For this subarray and this subarray, we have to apply the same technique. So here, recursively, we are going to apply the same procedure, and this 11 is at the correct position. So now, these elements that are less than 11. So these elements are less than 11, but are not in the sorted order. And these elements are greater than 11, but they are also not in the sorted order. Of course, they can be, but here in this case, they are not in the sorted order. So these elements can be arranged in many ways by applying some logic to the left of 11. So we can get 10, 2, 3, or it can be 2, 10, 3, or 2, 3, 10. Anything we can get based on the logic what we are applying. So these elements can be arranged in any ways based on the logic what we are applying in the partition. And in the same way, 16, 12, 17 or we can get 17, 16, 12 or 12, 16, 17 or 12, 17, 16, so on. So it can be anything. Okay, so it's not mandatory that they will be like this only. But that's for sure that all the elements to the right of this particular element 11 are greater than 11 and to the left are less than 11. So placing the pivot element that is 11 at the correct position is the backbone for this particular algorithm. Now, let us see the complete sorting of all these elements in the array by using the quicksort algorithm. So the array is having 7 elements, 11, 16, 2, 3, 10, 17 and 12 with pivot element as 11. And the index values like this 0, 1, 2, 3, 4, 5, 6. So the pivot element is what? If the name of the array is A, the pivot element is A of 0, that is 11. So this we can say as the lower bound and this we can say as the upper bound. So this is my lower bound and this is my upper bound. So lower bound value is 0, upper bound value is 6. Okay. So now simple thing is we have to find the proper place for this particular pivot element, that is 11. So that is less than 11 should be towards the left side and greater than 11 should be towards the right hand side. So what we can say is, if any element that is greater than the pivot element, we have to move towards the right side. And any element less than this particular pivot element, we have to bring towards the left hand side. So now we are going to consider two variables. One variable is the start variable and the other one is the end variable. So start variable we are placing here and end variable we are placing at this particular position. So here what we are doing, we are moving the start variable from this side to this, that is from left to right. And we are moving the end variable from this side to this side, that is from right side to left side. So we are moving the start variable from left side to right side and we are moving the end variable from right side to left side. So if we are going to move the start from left to right, obviously we are going to increase the start value because start initial value is 0. So now we are moving means we have to increase the start value. So we have to increase it one by one, not just start value is 0. Then second start value cannot be 2. It has to be 1. From 1, it has to go to 2, 2 to 3. So it has to increase by 1. So first it is 0, then it is 1, then it is 2, then it is 3, like this. And if we are going to move the end from right to left, obviously we have to decrease the end value, so that we have to decrement it by 1. Okay. So now what we are considering is, if we are going to increment the start, then we have to stop at some place. And if we are going to decrement this end value, then we are going to stop this at some place. So we have to find the condition where we have to stop. So if we are going to find any element that is greater than the pivotal element, then we are going to stop incrementing the start value. So this we can say it in another way like this. If any element that is less than or equal to this pivotal element, any element which is less than or equal to the pivotal element, then we are going to increment the start value. So in this case, the start value is 11 and the pivotal value is also 11. 11 is less than or equal to 11. The condition is true. So when the condition is true, what we have to do? We have to increment. So the start position came from this place to this place. So now my start is this one. Understood? Now 16 is greater than 11. Sorry, 16 is less than or equal to. So this we have to use less than or equal to condition for start. 16 is less than or equal to 11. The condition is false. So once when the condition becomes false, we have to stop incrementing the start value. So my start will be at this particular position. Now coming to end. So what about this end variable? From here, what we are going to find is the element. If it is less than the pivotal element, then we have to stop decrementing the end value. So what I mean by this, that is, if that particular value is greater than or equal to the pivotal value, then I have to decrement the end value. So here in this case, less than or equal to, in this case, for decrementing, greater than or equal to. Okay, so here we are going to, we have to stop this somewhere. So where we have to see, now let me check. 11 is greater than or equal to 11. Condition is true. So my end will become this. 17 is greater than or equal to 11. Condition is true. So my end will be this. 10 is greater than or equal to 11. Condition is false. So when the condition is false, I have to stop. So stopped at this position and stopped at this position. So start, I have used the maroon symbol, and for end I have used the blue symbol. Now what we have to do? Next we have to swap the elements. That is, this element I have to swap with this element. So 16 has to come to this position, 10 has to go to this position. So after swapping, the array will be something like this. End pointing to this position and start pointing to this position. See here, start 10 came to here, 16 came to this blue value. Understood? Again, we are applying the same funda. That is 10 less than or equal to pivotal 11. 10 less than or equal to pivotal 11. So what I have to do? I have to increment. So start will come here. 2 less than or equal to 11. Condition is true. So my start has to come here. 3 less than or equal to 11. Condition is true. So start will come here. 16 less than or equal to 11. Condition is false. So I have to start here. Start is maroon color. Now need to go with the end. 16 is greater than or equal to 11. Condition is true. So I have to go here. Decrement the end value. 3 is greater than or equal to 11. Condition is false. So I have to stop. Okay. So now we cannot swap these elements. Why? Because here the start value is greater than the end value. Once when the start value is greater than the end value, we cannot swap like how we have swapped here. Understood? So here, what we are going to do is, we are going to swap the end value with the pivot value. We are going to swap the end value with the pivot value. Okay, so now our array will be something. So end value, 3 value will come here, 11 value will come here. So our array will be like this: 3, 10, 2, 11, 16, 17 and 12. So this was our pivot element. Okay, so this was our pivot element. That pivot element came here. And the index values are 0, 1, 2, 3, 4, 5, 6. So the pivot element is placed at this particular position, that is with index value 3. And if you can check, the elements to the left of this pivot, that is 3, 10, 2 are less than 11. And the elements to the right of this thing, that is 16, 17, 12 are greater than this particular 11 pivot value. So from this we can say that the pivot element 11 is at the appropriate position. So now we have to apply the same funda for the partition, this partition, and to this particular partition. So here, now again, once again, my pivot value will become 3. And I am going to take same funda, same technique. That is, my start value will be this one, end value will be this one. Because this is one subarray and this is another subarray. So linearly, I am going to do this. Parallelly, I am going to do this one. So here, this is my start and this is my end. Same rule, what we have done in the previous. So this rule we are going to apply, and we have to sort. So in the same fashion, we are going to apply the funda of partition on this particular array and this particular array. So is that this particular approach, we are going to call it as an partition exchange sort. Fine. So if we are going to write this particular method into coding, we are going to have one function. That particular function, we call it as an partition. We are going to pass one variable a. That is a is the name of the variable. Then we have the lower bound and upper bound in the arguments. After that, what we do is we are going to choose the pivot element. So here, the first step, what we are doing, we are going to choose the pivot element. So what is the pivot element? The pivot element is equal to the lower bound. So pivot is equal to A of LB. Next, we have to consider two variables. One is start variable and the end variable. What is start variable? Start variable is 0. End variable is 6. That is, start is equal to LB. End is equal to UB, upper bound. Start is equal to lower bound and end is equal to upper bound. Now, what we have to do? We have to apply the loop, that is while loop. When A of start value is less than or equal to the pivot value, then we are going to increment the start value. So start plus plus. So we are going to apply this loop until this particular condition is true. Suppose if this condition is false, next what we have to do? We have to decrement the end value. Okay. So for decrementing the end value, again we are going to use the same while loop. While a of n greater than or equal to pivot, then we have to decrement the value. That is and minus minus. So if this condition is not true, or if this condition fails and this while condition fails, if both the conditions they are fail, so when this condition is failed, this condition is failed, what we are doing? See here, we are swapping. 10 came to this position, 16 came to this position. So what we are doing? We are swapping. So in this case, if you can notice that the start value is less than the end value. If the start value is less than the end value, then we have to swap. If the start value is greater than the end value, then we are not going to swap. So here in this case, we have to check the condition, that is if start less than end, then we are going to swap. Swap what? Start value with the end value. Start value with the end value. So end will be placed in this position, start will be placed in this position. So swap start comma end. And we have to repeat this particular process. See, here we did not stop, we repeated the process again. So once after placing the 10, I have moved the start to this position and the end to this position. So we are going to repeat this particular procedure. So here we have to repeat this procedure until the start value is less than the end. So we have to add one more loop, that is while loop, that is start less than end, like this. So here until the start value is less than the end value, we are going to perform this particular process. And we have to swap the pivot element with the end element. So here, if the condition is false, if the condition is false, that is start value is not less than end, start value is greater than the end value, then what we do? We have to shift this 3 I brought here and this 11 I brought here. So we have to swap A of LB with A of end. So we write swap A of lower bound comma A of n. And after that what we have to do is we have to return the end value. So here if you see, after swapping, I am returning the end value. Can anyone say why we have to return this end value? Because when we know this particular location, then only we can divide it into two partitions. So here when I return the end value, what is the end value? End value is 3. So when I return this particular 3 value, I know that I can divide the partition this part and this part. So one partition is from lower bound to this location, this particular location, -1, that is 3 minus 1, 2. And the other partition is location plus 1 to upper bound. So this is the main backbone for the quicksort algorithm. Now let us see how to write the code for the quicksort algorithm. Okay. So let us see how to write the code. So this is a very simple and easy way to write the code. So here in quicksort, we have to supply the array value, that is name of the array, lower bound and upper bound. If the lower bound value is less than the upper bound value, then we are going to call the method. That method is partition method. So if the lower bound value is less than the upper bound value, then we have to call this method. So how we are going to call? Partition A comma LB comma UB. A comma LB comma lower bound comma upper bound. And see here, the function partition which is returning the end value. So that end value we have to collect it in one variable which is of type integer. So LOC. So this LOC variable we have to declare somewhere in the program which is of type integer. And here again, if we can see, we are going to call the quicksort. So here we repeatedly, by using the recursive method, we are going to call the quicksort. So quicksort on the array A, lower bound to location -1, and quicksort on the array A to location +1 to upper bound. Understood? So here previously we have seen that it is going to return the end value, that is 3. So here this case it is on the array A, lower bound. What is lower bound? 0 to location -1, that is 3 minus 1, 2. So this is one quicksort we are going to call, and on this we are going, this is what is that? 3 is the location value, 3 plus 1 is 4. So location +1 is the lower bound and upper bound is 12. So this is how we are going to write the algorithm for the quicksort, and this is how we are going to write the algorithm for the partition. Now let us see the time complexity of the quicksort. Okay, so let us see the time complexity of the quicksort. Assume that the size of the file is file n is power of 2. So say that n is equal to 2 power m, so that our m value will be equal to log n to the base 2. Assuming that the proper position for the pivot always turns out to be exactly middle of the subarray. So in this case, there will be an approximation of n-1 comparisons in the first iteration, after which the file will be split into 2 subfiles, each of size n/2 approximately. So for each of these 2 files, there are approximately n/2 comparisons. So the total of 4 files, each of size n/4 comparisons, which may further yield to n/8 subfiles. So after having the subfiles for n times, there are n files which are of size 1. Thus, the total number of comparisons for the entire sort will be n plus 2 into n/2 plus 4 into n/4 plus 8 into n/8 plus n into n/n, which is nothing but it is n plus n plus n plus n, so on up to m terms. Because there are m terms, we are going to divide it into m times. So therefore the total number of comparisons is order of n into m, which is nothing but order of n log n. So the best case or the average case, the time complexity will be order of n log n. Now for the worst case, the time complexity will be order of n square. For this, the reason is, suppose now if the array is already in the sorted way, and say that the pivot value is in the correct position, then the original file is split into subfiles of size 0 and n-1. And if this process continues, a total of n minus subfiles are sorted. So n minus 1 subfiles are sorted. Then first one will be of size n. The second one will be of size n minus 1. The third one will be of size n minus 2 and so on. So assuming that there are k comparisons to rearrange the file of size k, the total number of comparisons to sort the entire list will be something like this, like n plus n minus 1 plus n minus 2 plus so on up to 2, which is our worst case complexity, that is order of n square. So here the efficiency of the quicksort method can be enhanced by choosing the better pivoty element, or by using better algorithm for sublists, or by eliminating the recursion. So that's all for now. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. For any online classes or for admissions, please contact me at 94944 70795. Thank you.